Now, when you're going to do a covalent molecule, there's a few things that you need to do. The first thing is you need to sum all of the valence electrons from all the atoms. Now, if it's not a molecule and it's an ion, the positive ions, you subtract electrons, and for negative ions, you add electrons. Now, once you've worked out the number of valence electrons, you need to write the symbols of the atoms involved to show how they're going to be connected. Now, usually, I'm saying usually, not always, usually, the central atom is the first one written. However, it's not always the case. The one that wants to make the most bonds is usually, I'm saying usually again, the central atom. So you have to work it out. So if it's got 4 valence electrons and it wants to make 4 bonds versus an atom that has 1 valence and only wants to form 1 bond, the one that wants to make 4 bonds is in the middle. You draw a single bond between atoms. Now, a single bond can be represented as a dash or 2 dots. Complete the octet. Now, octet is telling us they want 8 electrons in the outer shell. And you always start with the outer atoms to start with and not the central. Put any leftover electrons on your central atom, even if it means it's got more than 8. If there are not enough electrons on your central atom, so it hasn't got 8, and it's not an exception to the process, then you're going to have to try multiple bonds. And a double bond is represented as 2 lines or 4 dots, and a triple bond is represented as 6 dots or 3 lines. Now, there are some exceptions to the octet rule. Hydrogen only has 1 valence electron, and it's only got 1 principal energy level. So the maximum number of electrons that hydrogen can have in its shell is 2. So it's never going to have the octet rule. So it wants a maximum of 2 electrons. And to get 2 electrons, it's going to form a single bond. Now, beryllium's a bit unusual. It is considered to be a metal, but because it's such a small atom, it's got really, really high electronegativity. So it tends to form a covalent bond instead of an ionic bond. Now, it's got 2 valence electrons. So it can involve those 2 valence electrons in forming 2 single bonds or 1 double bond, but the maximum number of electrons it will end up with is 4 electrons. So it tends to like to share 2 more. Now, boron also has 3 valence electrons. It too will form a covalent bond. But this one here, because it's got 3 valence electrons, can form 3 bonds, so it will have a maximum of 6 electrons. Now let's look at how to do these examples. So let's start with a nice simple example of water. Now, each of the hydrogen atoms has 1 valence electrons, and there's 2 of them, so 2 times 1 is 2. Add oxygen has 6 valence electrons, so we've got a total number of 8 electrons to play with. Now, oxygen with 6 valence electrons is capable of forming 2 bonds because it needs 2 more electrons. But each of the hydrogens is only capable of forming 1 bond because it needs 1 more electron. So our central atom is going to be oxygen. And we're going to put the hydrogens around it. Now, to start with, we start by drawing a single bond. So I'm drawing 2 single bonds between the atoms showing how they're connected. Now, remember that single bond represents 2 electrons. Now we complete the octet for the outer atoms, and these are the outer atoms, and this is the central atom. Now, hydrogen, being special, only wants 2 electrons, and it's already encountered its 2 electrons there. This hydrogen is the same. It's already got its 2 electrons in the sharing of the electrons with oxygen. So our outer atoms have got complete shells. We need to now work out how many electrons we've got left over. We've used 2 plus 2 is 4, so we've got 4 electrons left over. Put them together. We must always keep them in pairs. And check, does our central atom have 8 around it? That's our key question. 2, 4, 6, 8. Yes, it does. How many electrons have I used? I've used 8. It's got 8 around it. Tick! I've done it correctly. Now let's try another example. PF3. Now, going to my periodic table, I can see that phosphorus is in group 15. So phosphorus has 5 valence electrons. Now each of the fluorines, being in group 17, has 7 valence electrons. 7 threes are 21, add 5 is 26 electrons. Now that's how many electrons we've got to play with. Now, because phosphorus has only got 5 valence electrons, it wants 3 more. So it is capable of forming 3 bonds. Fluorine, on the other hand, has got 7 valence electrons and only needs 1 more valence electron. So it's only capable of forming a single bond. The one that is most capable of forming the most bonds goes in the middle. And you'll notice here that the central atom has been written first. So we put phosphorus in the middle, and then fluorine, fluorine, and fluorine. Next step, we have to put single bonds. That's our start point. So we put single bonds between the phosphoruses and the fluorines. Now we complete the octet for the outer atom, and each of these fluorines is the outer one. So we put them in around it. So this fluorine now has got 2, 4, 6, 8. Notice I'm keeping my electrons in pairs. This fluorine currently has 2, 4, 6, 8. Same with this fluorine, 2, 4, 6, 8. Now we need to check the total number of electrons we've used. We've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. If we go back here, we said we had 26 electrons. So the last 2 electrons get put on the central atom. The final question, does our central atom have 8 electrons? It's got 2, 4, 6, 8. Yes, it does. Tick. I've done it correctly. Now let's try another example. This time we're doing carbon dioxide. Carbon is in group 14, so it has 4 valence electrons. Each of the oxygens is in group 16, so that means we've got 6 valence electrons. 2 times 6 is 12, add 4 is 16 electrons. So that's how many electrons we have to play with. Now carbon with 4 valence electrons is capable of forming 4 covalent bonds. Each of these oxygen with 6 valence electrons, needing 2 more valence electrons, is capable of forming a double bond or 2 bonds. Which atom can form the most bonds is carbon. So carbon becomes our central atom. We put carbon, oxygen, and oxygen. Now, we always start with single bonds. So we start with a single bond and a single bond. We complete the octet for the outer atom. So 2, 4, 6, 8, 2, 4, 6, 8. Now we check our electron count, which is 2, 4, 6, 8, 10, 12, 14, 16. So I've used up all my electrons. Does my central atom have 8? In fact, it's only got 2, 4. So this is wrong. So we need to go to the next step, which is to try multiple bonds. So I'm going to try again, this time with a multiple bond. So this time I'm going to put a double bond here and a single bond here. I complete the octets for the outers, 2, 4, 6, 8, 2, 4, 6, 8. Do my electron count, 2, 4, 6, 8, 10, 12, 14, 16. I've used up all my electrons. Does my central atom have 8? 2, 4, 6. No, it is wrong. So over here I'm going to try again. This time I'm going to put a double bond on the other side. So complete the octets for the outers. 2, 4, 6, 8. 2, 4, 6, 8. Check your electron count. 2, 4, 6, 8, 10, 12, 14, 16. That's good. Does my central atom have 8? 2, 4, 6, 8. Yes, it does. Tick. I've done it correctly. Now let's try a third example. Hydrogen, remember, has 1 valence electron. We're going to add carbon. Carbon being in group 14 has 4 valence electrons. And nitrogen being in group 15 has 5 valence electrons. So we're starting with 10 electrons. Now let's work out what can be central. Hydrogen is only capable of forming a single bond. Carbon is capable of making 4 bonds, and nitrogen is capable of making 3 bonds. Now remember how I know this. Carbon with 4 valence electrons wants 4 more electrons, so it's capable of making 4 bonds. Nitrogen with 5 valence electrons needs 3 more electrons, so it's capable of making 3 more bonds. So we should be asking ourselves, what can make the most bonds, because that is going to be the central atom, and in this case it will be carbon. And you'll notice it's set up almost exactly how it's written. So we start with single bonds between them. Now complete the octet for the outers. Well, in this case it's nitrogen needs 8, 2, 4, 6, 8. Now hydrogen, being an exception, only wants 2 electrons, which it gets from its shared pair. So check our electron count, 2, 4, 6, 8, 10. That sounds good. Does our central atom carbon have 8? No, it doesn't. So this is wrong. Start again. This time we're going to put a double bond between carbon and nitrogen. We cannot make a double bond with hydrogen because it's not capable of taking more electrons. Complete the octet for the nitrogen, 2, 4, 6, 8. Check our electron count, 2, 4, 6, 8, 10. Does our central atom have 8? 2, 4, 6. No, it doesn't. It's wrong. Try again. This time with a triple bond with nitrogen. 2, 4, 6, 7, 8. Check our electron count, 2, 4, 6, 8, 10. We've used all our electrons. Does our central atom have 8? 2, 4, 6, 8. Yes, it does. Now it's time for you to try some yourself. So I would like you to go to the OneNote under bonding, covalent, electron dot diagrams, and try ZA. If you get stuck, don't worry, we're going to do some in class next lesson.